Hello YouTube, welcome to another Basic Chemistry SAT Chemistry video, and in this video we're going to cover the 1998 SAT Chemistry exam from number 64 until number 85, which is the end. Now it's number 64. So in this question, we're supposed to find which of the following is the weakest acid. So you guys should know that if it has a high Ka value, it means it's a strong acid. And if it has a low Ka value, it's a weak acid. Therefore, you just need to find the choice with the lowest Ka value, and that will be A. Because 4 times 10 to the power of negative 10 is smaller than all of the other values. Number 65, the structure of CH4 is best described as. So the CH4 molecule looks like this. And this is a tetrahedral structure. So these are just one of the things that you just know by memorizing the Vesper theory. So yeah, you just need to memorize all of the atomic shapes like tetrahedral or bent or trigonal planar or trigonal bipyramidal, stuff like that. 66. A drying agent is not suitable for removing the water vapor from a sample of gas, blah blah blah. Okay. So this one, the answer choice is O2, because oxygen can be dried by NaOH. And again, this is another thing that you just know. Number 67. Both of the gas samples represented above, blah 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 blah. Okay, so here we know that 1 liter has 0.2 grams of H2 and 2 liter has 8 grams of gas X. So we know that if it's at the same temperature and pressure, all gases occupy the same volume, no matter how large or small their molar mass are. And we know that in 1 liter of gas, or rather in 1 liter of a container, there can be 0.2 grams of H2. And because we know that H2 has a molar mass of 2 grams per mole, we know that 1 liter equals to 1/10 of a mole of a gas. And this applies to any gas. And now here, we see that at 2 liters, it occupies 8 grams of gas X. So because 10 liter equals to 1 mole of a gas, because 1 liter is 1/10, so you just multiply 10 by both sides, we just have to multiply 2 liters by 5 and 8 grams by 5. And we know that 10 liter, 40 grams of gas X, and 40 grams is basically 1 mole, because at 10 liters there should be 1 mole of gas, so the answer should be C. 40. 68. The equilibrium constant for the reaction is given by the expression. So the equilibrium constant, or K, should be the product with the coefficient at the top, or it should be the power multiplied by the product. Again, the coefficient should be a power and O2, because those are the products. These are the, or rather, these are the reactants. These are the products. And the formula is basically oops. And that should be N over reactants. And N is basically the coefficient. So here the answer should be D. 69. Suppose a 0.8 mole of NO is converted to NO2. The amount of heat involved would be. Okay. So here we know that in the reaction, we know that 2 mole of NO, if it's converted, you get 150 kilojoules of energy. So if 0.8 mole of NO is converted, how many kilojoules is it? That's pretty simple, right? You just need to do 2 divided by 2.5, which is 20 over 25. So 20 over 25 equals to 4 over 5 or 0.8, right? So we just need to divide 150 by 2.5. And 150 divided by 2.5, I believe, should be D60. 60 grams of nitric oxide and 60 grams of oxygen are available. What is the maximum number of nitrogen dioxide that can be produced? So let's make an ice table for this. Okay, so we say that there's 60 grams of NO, which is 2 moles, and 60 grams of O2. And O2 has a molar mass of 32 grams per mole, so we're going to just do 60 over 32 mole. That should be 0, 0. Remember, the coefficients has to be be equal, so that should be minus 2 mole, minus 1 mole, or 32 over 32, plus 2, and there shouldn't be anything in the heat actually. That should be 0. I believe that should be 28 over 32 mole remaining. So basically the O2 is the limiting, or the excess reactant. 2 mole. Now we know that 2 moles of NO2 or nitrogen dioxide can be produced by 2 moles of nitric oxide, so that should be B, or 60 grams, or rather 46 times 2, because NO2 has a molar mass of 46. 46 times 2 is 92. C. 71. So in 71, you guys should note that metal oxides plus water equals to base, and non-metal oxides plus water equals to acid. So because this question is asking of which solution gives the most acidic solution, we just need to find the non-metal oxide, right? So sodium is a metal, calcium is a metal, aluminum is a metal, zinc is a metal, and SO3 is the only non-metal. So you could just highlight SO2. SO2 is the answer, because H2O plus SO3 equals to H2SO4, which is sulfuric acid. So another trick that you can use in questions like this is to eliminate all the common choices. So among the choices here, we see that all of these 4 are metals, so we could all eliminate them, and the only odd one, the only one that stands out, is choice E, because it's the only non-metal oxide, so you can also do it that way. 72. So in 72, we say that initially it's at the gas is at 23 degrees Celsius, and 750 millimeters of mercury. But now you switch it, or rather you change the temperature, and you increase the pressure. So what happens when there's a decrease in temperature? Decrease in temperature also means decrease of volume, because the Charles's law states that V1 over T1 equals to V2 over T2, or that volume is directly proportionate with temperature. So with the temperature decrease, volume decreases, because obviously the gas molecules or the gas particles move with less kinetic energy, so they obviously occupy less volume. Now what happens if there's an increase in pressure? If there's an increase in pressure, pressure increases, the volume decreases, because Boyle's law says P1 V1 equals to P2 V2, or that P is inversely proportionate to volume. So basically, among the choices, we need to choose. Okay, let's look at the first thing that you multiply with. So this is a pressure, right? And because the pressure is supposed to decrease in the newly given volume, so this is the new volume. And because there's an increase, right, in pressure, there should be a decrease in volume, as I stated before. So what do you need to do? Because the final value of the volume should be smaller than 200 milliliters because there's a decrease in volume, you need to find a value that is lower than 1, or a value that will lower the value of 200, right? So you can immediately eliminate choice A. That's not the answer. Choice C and choice D. Because if you choose any of the A, C, or D, you would basically be saying that a decrease or an increase in pressure increases the volume, so that would be incorrect. And let's look at the second value here. So this is the temperature, right? The temperature converted to kelvins. So because you always need to convert it to kelvins, you also know B is not the answer, because B is just in Celsius. And you can convert it to kelvins easily by adding 273. So 23 plus 273 equals to 296 kelvins, and 0 plus 273 just equals to 273 kelvins. And again, because there is a decrease in volume, we need to find the value that will lower the 200 again, and that value is E, or the choice would be E, because you multiply it with the pressure value, which is lower than 1, and you also multiply by the temperature value, which is also lower than 1. And you want that because in both cases there will be a decrease in volume. However, if the question said that the temperature increases, temperature increases, so let's say like 100 degrees, then you'll need to find a value that is over 1. So in this case, if it says 100 degrees, there'll be an increase in volume, right? And there'll be something like this, 200, or rather, increase in temperature will be something like this. 200 times 750 over 760 times 373 over 296, assuming that the pressure is kept equal. Moving on to number 73. Number 73, we're looking for a reduction reaction. So let's see. Number 1. Number 1 is basically counterintuitive, because if you add an electron to Fe2 plus, it should be Fe plus, not Fe3 plus. That's incorrect. B. Okay, B, you add an electron and that turns into Fe2 plus, and gaining an electron is indeed a reduction, but here it's looking for the reduction that happens in the reaction represented above. And the reaction represented above, there's no part that says Fe3 plus electron turns into Fe2 plus. It's actually the other way around, so this is also incorrect. C, Fe2 plus turns Fe3 plus E minus. Now this is this may be something that happens in the reaction, but this is not a reduction. This is oxidation, because it loses E minus, which is oxidation. So that's also incorrect. D. Okay. D, there's no change in the oxidation states. +1, -2, +1, -2. So it should not be the answer, because there's basically no change in the oxidation states. So this is not the answer. E. So let's look at E. E is the only one remaining, and it should be the answer, but let's double check. -2 +7 +1 +2 +1 -2, and we can see that the manganese gained 5 electrons, and which means that it was reduced. Therefore, it's the oxidizing agent. So the answer should be E. 74. So 74. This is probably the I would say the most confusing or the most difficult question in the exam. These type of questions, but it's actually not that complicated to solve. So we see that the biggest gap in between these numbers. So in between these numbers, is these two values. Between these two, between the second and third electron, there's a huge jump in the ionization energy. So that probably represents that as the second electron is removed, it moves on to a whole new shell, which dramatically increases the ionization energy, because obviously an atom with a full shell has more ionization energy than an atom with let's say 1 or 2 valence electrons. So I can predict that the atom looks something like this. There's 2 electrons and 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2. So you move, let's say you remove the first one. You remove the second one. And what will happen? If you remove the first one and the second one, you'll be left with a full shell that has 8 electrons, which means increase in ionization energy. Right, so that makes sense. And an atom with 2 valence electrons, or this atom would have 12 electrons, and I believe 12 electrons is calcium, right? So let's say, for example, calcium. And calcium forms an ion of Ca2+, so the answer is B. Because when it has 2 valence electrons, it'll want to lose those 2 valence electrons, which will give it 2+ positive charge. Or rather, sorry, the it should not be calcium, but it should be magnesium. 2+ magnesium, because magnesium has an atomic number of 12, but that won't make much of a difference for the answer. It'll still be B. 75. Lowest first ionization potential. So we're basically looking for the choice that has 1 valence electrons, because alkali metals or any atom that has 1 valence electrons will have a very, very low first ionization energy, because it will want to get rid of that electron to comply with the octet rule and gain a full shell. So let's just look at the choices that has 1 valence electrons. Choice A has 9. Choice B has 10. Choice C has 11. Choice D has 12. And choice E has 13. So which element has 9 electrons? You'll be given the periodic table in the exam, so you can just find it easily. A. 9 electrons, that's fluorine. It has the highest, or rather, it has 7 valence electrons, so its first ionization energy cannot be the lowest. B, 10 electrons. That is neon. That's a noble gas, so it should have one of the highest ionization energies. Number C, or letter C, choice 11, sodium. Sodium has 1 valence electrons. It's an alkali metal, so it should be C. Let's keep looking at the other choices. D, 12 electrons. 12 electrons, magnesium. Magnesium is also, it also has quite a low first ionization energy, but because it has 2 electrons, it should have a higher first ionization energy compared to choice C. That's incorrect. D, 13 electrons, boron, incorrect. So the choice is still C. Okay, let's number 76. 250 grams of hydrated salt. Is heated until all the water is evaporated. So the water is evaporated. And then you get 160 grams. So what does that say? That says that comparing the hydrated salt with the dehydrated salt, there's a 90 gram difference. So we can say that this 90 gram is the mass of the water, right? So if we want to find the percentage occupied by the water, we can just do 90 over the overall value, which is 250. So 90 over 250 times 100% to find the percentage. And so the choice would be D. But let's double check with the answer. So 90 over 250 times 100 is basically 9 over 25 times 100. That's 900 over 25, which is equal to 36%. So 250 times 0.36 or 36% should be 90, right? So we know that's the correct answer. 77. 77 is basically asking if any of these acids have a concentration of 0.001 molarity, it will have a pH of 3 because pH equals to negative log H plus, and if you do negative log 1 times 10 to the power of negative 3, you'll basically get 3, right? So it's a pH of 3. So if we know that has a concentration of 0.001 molarity and has a pH of 3, that means at 0.01 molarity it'll have a pH of 2. And at 0.1 molarity it'll have a pH of 1. So we know that's a very, very strong acid. Oh, and this happens because every decrease in pH by 1 means it's 10 times more acidic. So anyways, we know it's a very, very strong acid because even at a concentration of 0.001 molarity, it'll still have a pH of 3, which is acidic. So let's look at the choices. A, acetic acid, or C2H2O. 2 is a weak acid. HCl is a strong acid. That should be the answer, but let's keep looking. Sodium bicarbonate, that's a base. Nope. Sodium hydride is also a base. Sodium hydroxide is also a strong base. The answer choice should be B. So in this question, number 78, we're looking for species that are acting as the acids or by the Brown-Lowry acid definitions, proton donors. So here we can immediately know that H2O gives up one hydrogen cation or a proton, which makes H2O an acid here, right? So H2O is the acid. S2, or sulfur, is a base. Therefore, this should be the conjugate base, conjugate acid. So these are the pairs here. So basically, we want to know the species that are acting as proton donors or acids. And we know that the choices should be the acid and the conjugate acid, which is HS minus. So the choice should be B. 79. Okay, it says that X has 9 electrons and 10 neutrons. Oh, and 9 protons. Because we know that the atomic number basically means the number of electrons and protons, and you subtract that from 19, you get 10 neutrons. And for element Y, it has 10 electrons, 10 protons, and 9 neutrons. So choice A, they are isomers. They're not isomers because they do not have the same number of atomic number. Isomers are basically things that have the same atomic number but have different number of neutrons. That's incorrect. B, or rather, they're not isotopes. B, they're isomers. They're definitely not isomers because isomers are related to the atomic structure. They're not isomers. C, they're isoelectronic, which basically means that they have the same number of electrons. Incorrect. 10. They contain the same number of neutrons in the atoms. We see that one has 10 and one has 9, so that's also not the choice. E. They contain the same number of protons plus neutrons in the atom. And this is true because we see that it has a mass number of 19 and it has a mass number of 19. And mass number equals to proton number plus neutron number. Choice is E. 80. Some solid crystalline compounds slowly change to the gaseous state when left at room temperature in an open container. So we know that it's talking about sublimation, where solid change to gas. Which of the following is true about this phenomenon? A. It is accompanied by an increase in temperature. B. It is accompanied by an absorption of heat by the solid. C. It is a result of a chemical reaction with air. D. It is best described as fusion. E. It is observed only with ice. E is definitely not the choice because we know that iodine sublimates too. D. Is it fusion? No, it's not fusion. If you say heat of fusion, it's basically saying melting, so it's not fusion. C, it is a result of a chemical reaction with air. Nope, that's not true. B, it is accompanied by an absorption of heat by the solid. So the choice would be B. And A is not correct because sublimation is not accompanied by an increase in temperature. Because even if temperature does not increase, a substance can still sublimate. B, so why is it accompanied by an absorption of heat by the solid? And that is because things sublimate because they have a weak intramolecular bond, like iodine. It only has London dispersion forces, so the atoms can freely break away from the intermolecular bond, which makes it a gas because solid particles are hold together tightly, while gaseous particles are rather set free. So when it absorbs heat, it receives energy, so it can free those atoms or those particles easily. So it should be B. 81. A test tube with carbon dioxide that gas is inverted over the water as shown above. The gas becomes more solid when the water. Okay, this question we know that's related to solubility of gas, and gases become more soluble if there are lower temp and higher pressure. So basically we know A is not true, because if temperatures increase, gases become less soluble. Gas is heated, no, it needs to have the lower temperature. C, lip of the tube is moved to level 1. If the lip of the tube is moved to level 1, it'll have less pressure. It'll have a or rather a weaker pressure, so C is not the answer. D, lip of the tube is moved to level 2. Okay, if it's moved to level 2, it'll have more pressure, right? So D should be the correct answer. But let's keep looking at number E. The amount of gas in a tube is reduced. E. No, that does not have to do. That's not that relevant to the solubility of gases, so the choice should be D. 82. Which of the following molecules, or a molecule of which of the following compounds contains a double bond? So here we actually need to draw these. So we know that carbon has 4 valence electrons, so it can only form 4 bonds, right? Let's draw A. A looks like this, and branches are just carbons. So this does not contain a double bond, so it's not A. B, C2H6, okay. 1, 2, 3, 1, 2, 3, that also does not contain a double bond. C2H4. C2H4 basically looks like this. Or it's an alkene, so it does contain a double bond. This should be the correct answer. And the rest are incorrect. 83. Okay, it says the system is at equilibrium in a closed container. Decrease in total volume of each container increase the number of moles of products for which system. So it's saying that if you decrease the volume, it increases the number of moles of the product. So according to Le Chatelier's principle, if you decrease the volume, the number of moles of product will increase at the side with less moles, right? So here we see, or it will increase, for the less mole. So A, we see that there are 5 mole here, 7 mole here. It's incorrect. We see there's 2 mole here, 2 mole here, and that would basically make no difference. That's also incorrect. And here we see there are 2 mole, 2 mole. Incorrect, won't make a difference. And then we see there's 3 mole and there's 2 mole. And that should be the correct answer, because choice E, there are also the reactant side and the product side. Or the reactant side has 2 moles, but the product side has 4 moles, so that's also incorrect. So it should be D, because if you have less moles on the product side and you decrease the volume, the number of the reaction will shift to the right, or to the product. 84. Okay, when 1 mole of chlorine gas reacts completely with a excess KBr or potassium bromide solution as shown above, the products obtained are Okay, so here it's asking that when Cl2 plus KBr react 1 mole, right? The product obtained R. Okay, so product obtained here should be the 2 moles of Cl minus ions. So 2 moles of Cl minus ions plus and if you just put a 2 there, it should be Br2. So the answer should be D. And of course, oh, here the K is also free. So yeah, so the answer should be D. 85. All the following statements about ammonia and H3 are true except, so ammonia does have a characteristic odor, so A is not correct. There's a liquid at room temperature. Actually, there's a gas at room temperature, but let's keep reading. I'm guessing B is the answer. C, it is very soluble in water. Yes, ammonia is very soluble. Ammonia is indeed very soluble in water, and that's why you can't collect it by collect it over water. D, its aqueous solution has a pH above 7. That's correct because ammonia is weakly basic. E, it readily reacts with acid. Yes, that's true. So we know it's B. So that's it for the 1998 SAT chemistry exam. If you have any comments, or any questions, you can leave in the comment below and join the Discord channel to ask any chemistry related questions. And in the next video, we'll come back with another SAT chemistry exam.